Hi everyone! So today we're talking about calculating and organizing data. And what that means is we're going to use an equation in terms of geometry to help us to track some data and make some assumptions and graph. So the equation we're using is the sum of the interior angles. And what that is 180 multiplied by n minus 2. And you might see here we have some parentheses around the n minus 2. That's our invisible multiplication sign, right? So in this sense, we are going to be doing n minus 2 first and then multiplied by 180. So why 180 degrees? Well, when we look at a straight angle measure, we have 180 degrees. It's 1/2 of a circle. And if you are a skateboarder or a rollerblader or a mountain biker, you might be familiar with that kind of terminology. A complete rotation angle measure is 1 full circle, and that is equal to 360 degrees. Again, so if you spin around in a full circle, you're at 360 degrees. When I'm talking about the interior angle sum, I'm looking at the inside angles of a regular polygon. So there's 1, 2, 3 inside the triangle. And the sum inside my triangle is going to be equal to 180 degrees. Now you might say, how do you know that? Well, let's reference a square. And based on the properties of a square, we know that each interior angle, each inside angle of the square is equal to 90 degrees. And we know that by definition. So when we're looking at a square, we can notate that each of the angles in the inside of the square is 90 degrees. And we do that by drawing a little square in the corner of each vertice. Okay? Once I have 90 degrees in each corner, well, I have 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees, and that tells me all together inside my square I have 360 degrees. Well, if I'm just looking at half of that square, I have a triangle. Now, instead of looking at that 90-degree angle, I'm looking at half of it, which is 45 degrees. So inside my triangle, I have one 90-degree angle and two 45-degree angles, which equals 180 degrees. Now, in my previous example, I had 45 plus 90 plus 45, but that is not necessarily the case for all triangles. But it is true that all triangles will have a sum of 180 degrees. So now, if I'm using my equation, 180 times n minus 2, n is equal to the number of corners of my shape. So for a square, n is equal to 4. So 180 times n minus 2 is going to give me 180 times 4 minus 2, or 180 times 2. And that's going to equal 360 degrees. Now for my next regular polygon, I have a pentagon, which has 5 sides. So again, I'm looking at that 180 times n minus 2. And now I have 180 times 5 minus 2. And that's equal to 180 times 3. And that's going to equal 180 times 3. Down my 0, 8 times 3 is, there we go, 540 degrees. Now that we've used this equation, we can actually think about it in terms of data. So I might ask you to build a data table with all of these different interior angle sums. Now, if you remember, we talked about a straight angle equaling 180 degrees. That's 1/2 of a circle. If I take 180 degrees and subtract the interior angle, that will equal the exterior angle. That's the angle on the outside of my polygon. Okay, so take another look at that equation and make sure that you can apply it accurately. And we're going to use it to build some data sets in class.